Hi everyone, we're so glad that you're joining us at the Mill Creek Alliance for another MCA Café, where we occasionally get together and explore a question to better understand and manage water and environmental quality. The Mill Creek Alliance is a nonprofit organization in Cincinnati, Ohio, and we champion the Mill Creek watershed as a natural and community asset. So let's get started thinking about the basic question of what is a stream? It's important to use our terms carefully. When people think of a stream, they're thinking about the stream channel where there's free-flowing water moving on top of the surface of a stream bed. But water also moves through the stream bed and it is contained on the sides by a stream channel. A stream corridor is composed of the stream channel and its riparian zone, which is a transition zone between aquatic and terrestrial systems. It's an area which separates the stream from the uplands, and it's an incredibly high valuable area protecting the physical structure of the stream corridor, producing a large quantity and diverse range of trees, edible fruits, and nuts that support wildlife. A riparian zone may be located within a floodplain, a level area near the channel formed by the stream and is regularly flooded during moderate to high flow events. Let's explore the size of these parts of a stream at a restoration project of a tributary in Sharonville, Ohio. You can see its stream channel is 200 feet wide from side to side as it flows from top to bottom of the photograph. You can see a highway on-ramp on the left and motel on the right, which are likely located in the floodplain, but how can we check? How wide is the floodplain? Let's keep in mind the image I showed of a stream corridor. To determine the location of a floodplain, FEMA, Federal Emergency Management Agency, maps are regularly used. You can see the 200-foot wide tributary flowing from top to bottom of the image between the highway on-ramp and the motel, and the blue-green color of the map indicates the 100-year floodplain having a 1% chance of flooding in any given year, and the brown color indicates the 500-year floodplain, which is less likely to flood. In this map, you see that the 200-foot channel is part of a much larger floodplain system, and the inset shows the orientation of the channel within its 5,000-foot floodplain. It includes a considerable amount of development. Well, streams change across space along their length from upstream to downstream, and a well-functioning stream is heterogeneous. It varies and changes. Streams typically have a sequence of deep pools of slow-moving water that alternate with shallow riffles of fast agitated water. A run of fast water and a glide of slow-moving water may also be part of the sequence, and then the pattern repeats again and again. And it improves water quality and the biology of the stream. Here are some more images from that same stream reach from the other stream bank, and it gives another view of the pool riffle sequence. You can see a flock of geese feeding in the oxygen-rich riffle and resting in the slack pool. Well, the same is true of other birds, fish, and reptiles, and you can see variations in the amount of vegetation and no doubt the type of vegetation that varies with the conditions in the riparian zone. Not only do streams change with space, they change with time. In this image, you can see Amanda Noor, watershed specialist with Hamilton County Parks, surveying part of Sharon Creek. You see the stream is shallow and wide with cobbles deposited in the stream. On the right, you see leaning trees, slumping stream banks, and that Amanda is about 20 feet lower in elevation than I am at the top of the stream bank. Sharon Creek is not static. It didn't always appear this way. The stream channel is evolving and changing. In a natural state, a stream channel is stable. After a disturbance to the hydrology or lithology of the stream, we see the system becomes unstable, perhaps due to increased force of water added during flooding events, or perhaps development that destabilizes the stream banks. The banks become steep and are incised because they're sharply cut. We then see widening of the stream bank as the extra energy in the stream carries away sediment. The stream banks may have small landslides as earth slumps into the stream channels, and even trees are undercut as earth erodes from under their roots. Let's quickly review the previous photo. We see all of those features of an evolving stream channel. We see widening, we see incision, and we see slumping earth. Over long periods of time, the material deposited in the stream will accumulate in the stream channel and create terraces or benches that may result in a more stable stream corridor where a new floodplain develops and is stabilized by vegetation. The process can take hundreds or thousands of years. Many of our approaches in stream restoration accelerate this natural process to achieve a stable new equilibrium in a few years. Well, thanks for joining me. If you'd like more resources, take a stream walk or simply choose one nice place to look for the signs of changing streams, including changes in space along their length and knowing that there are changes across time as the stream channel adjusts and evolves to some kind of disturbance. You can visit the FEMA Flood Map Service Center and search for locations of interest. Come back, see more MCA Café videos in environmental restoration, education, and recreation. Thanks for joining us. Get involved, get in touch. See you again.